Mars is named after the Roman god of war because its reddish color reminded people of blood. Many people have wondered if there's life on Mars. Scientists have been looking for answers. Mariner 4 was the first mission to make it successfully to Mars. It arrived in 1965. The Mariner missions took many pictures of the red planet and its moons. Viking 1 was launched on August 1975, followed later that year by Viking 2. These spacecraft were able to land on the Martian surface using parachutes and retro thrusters. Many pictures were sent back from those landers. The Viking landers monitored Martian weather, regular dust storms, and returned color photos which revealed interesting geologic features. Pathfinder landed on the surface of Mars July 4, 1997. The goal of the Mars Pathfinder mission was to analyze the rocks and soil of Mars. In an effort to understand more about Mars, NASA developed twin robot geologists, Spirit and Opportunity. Spirit was launched June 10th, 2003, and Opportunity July 7th. These rovers have special tools to take photos and analyze soil samples. By learning about Mars, scientists may learn more about the development of planets and even our own Earth.
Today's lesson is autonomous waypoint navigation in natural terrain. This is your designated goal location. First, watch this video to learn how it's done.
A robot exploring natural terrain needs to continually find and avoid navigational hazards such as large rocks and steep slopes. Our system models the terrain using stereo vision, determines and stores how safe the rover would be at each location in the model, then estimates the traversability of several possible driving paths. The rover chooses the safest path that moves it closer to its goal and drives a short distance along that path. This process of taking pictures, predicting rover safety, and driving continues until the goal is reached. The first step of the navigation cycle is to take pictures. A pair of cameras at the front of the rover captures simultaneous left and right images of the terrain. Features in the image pair are correlated and triangulated to determine the distance to the feature from the cameras. Range data must satisfy a number of tests before being accepted as correct. Confusing or misleading features, like parts of the vehicle and areas of the image seen from only one camera, are automatically removed from consideration. The resulting points are accumulated into a three-dimensional geometric model of the terrain. This 3D model is evaluated for safety across a grid at rover wheel resolution. For each grid cell, points within a rover-sized patch are fitted to a plane and rated for traversability. Each patch is checked for steps, excessive tilt, and roughness. Obstacles are expanded by the radius of the rover, so that the rover center will stay far enough away from the obstacle to keep the entire vehicle out of danger. Each patch is accumulated into a gridded traversability map that drapes across the terrain near the rover, including areas not currently visible from the cameras. A small number of paths are superimposed onto the map and evaluated both for safety and also closeness to the navigation goal location. The rover chooses the safest path that gets it closer to its goal and drives a short distance along that path. After each step, the navigation process repeats until the goal is reached, no safe path is available, or the rover is commanded to stop.
Now it's your turn to try. Oh dear, maybe we should watch that video one more time.